Hey there everyone, welcome back to my new lecture. Today we're going to be talking about simultaneous equations. We're going to be solving every single question from exercise 2.5, starting with the first question. But before moving on to the first question, we need to know what's covered in this video. I'll be talking about the linear equations and homogeneous quadratic equations. What are homogeneous equations? Do you have a guess? If not, here's the definition. Homogeneous quadratic equations or homogeneous equations are those equations that have variables x and y or a and b, and they are constants. On the right side, instead of any other integer, we have 0. Starting with the first question, we need to solve the system of equations. This is the first case. We have got a linear equation and a quadratic equation. Do you have an idea of how we could solve these equations? If not, let me just tell you. The method is to make y or x, which is the variable, the subject of the linear equation, and then we can substitute that into our quadratic equation. If you look at the first example, we have 2x plus y is equal to 1. So if we are finding the value of y, we can bring 2x to the right, and that becomes y is equal to 1 minus 2x, as the sign has shifted from the positive to the negative. Now with this value of y, we can place it in our second quadratic equation, which is x square plus y square is equal to 10. So instead of writing it like that, we can write x square plus 1 minus 2x whole square is equal to 10. Now 1 minus 2x whole square, that looks a lot like the second identity, which is a minus b whole square. So we can expand this equation and write x square plus 1 plus 4x square minus 4x is equal to 10. Now, if you look at x square and 4x square, they both get added with each other, so that results to 5x square. If you take 10, which is on the right side, and bring it to the left, that becomes negative 10. So 1 minus 10 is negative 9. So our new equation is 5x square minus 4x minus 9 is equal to 0. So this is a pure quadratic equation in the form of ax square plus bx plus c is equal to 0. Now how can we further solve it? We can factorize this equation. So we can find the factors of negative 4x, and that is minus 9x plus 5x. So when we solve this quadratic equation, we get the roots of 5x minus 9 into x plus 1 is equal to 0. For the first value of x, if we bring negative 9 to the right side and divide both sides by 5, we get x is equal to 9 by 5. And for the second value of x, that's just negative 1. So we have got the value of x. The first is 9 by 5 and the second is negative 1. We can place them in this first equation, which is 2x plus y is equal to 1. So what do we get the value of y? For the first case, we get negative 13 by 5, and for the second case, we get 3. So what will our solution set look like? We can write for the first case, x comma y is equal to 9 by 5 comma negative 13 by 5. And for the second case, we can write x comma y is equal to negative 1 comma 3. So I wrote the solution set in the form of an ordered pair. Here, as you can see, this is the solution set. Moving on to the second question. Here we have again got the system of equations, and they all follow the same case which we studied in the previous question. We have got a linear equation and a quadratic equation. What I want you guys to do is to try to attempt this question by yourself. If you're successful, you can check and verify the answer. Make sure to pause the video for a few seconds and try to attempt it yourself. Okay, so here we have 3x minus 2y is equal to 1, and x squared plus xy minus y squared is equal to 1. So if you look at the first equation, we can bring negative 2y to the right and divide all sides with 3. That means that x will be equal to 1 divided by 3 plus 2y divided by 3. This is the value of x. Now we can substitute this new value of x into our second equation, which is a quadratic equation. Why are we calling it a quadratic equation? Do you guys have a guess? That's because the highest power here of the variable x square and y square is 2. That's why it's known as a quadratic equation. So we can find this value of x and just place it into our second equation. Instead of writing x square plus xy minus y square is equal to 1, we can write 1 plus 2y whole square plus 1 plus 2y divided by y minus y square is equal to 1. I'm sorry for making a mistake. This is not division. It's actually the into sign, which means multiplication. Now, if you look at 1 plus 2y whole square, it looks a lot like the first identity, which is a plus b whole square being equal to a square plus 2ab plus b square. So we can expand this and write 1 plus 4y square plus 4y plus 3 into y plus 2y square minus 9y square is equal to 9. So our new equation is y square plus 7y minus 8 is equal to 0. We're going to use the factorization method. So for the factors of 7y, they are 8y minus y. Now we found the roots of the equation, which is y minus 1 and y plus 8, which is equal to 0. If we bring negative 1 to the right side, that means that the value of y is equal to 1. And if we take positive 8 to the right, its sign is going to be changed, and that means y is equal to negative 8. So for these both values of y, we can place them in the first equation, which is a linear equation, and find the value of x. So for the first case, we can write 3x minus 2 into 1 is equal to 1. That means 1 plus 2, 3 divided by 3 is 1. So if the value of y is 1, the value of x is also 1. So what's going to be the solution set for this first case? It's going to be x comma y is equal to 1 comma 1. And for the second part, if the value of y is placed as negative 8, 1 minus 16 divided by 3 is negative 15 over 3, and that's negative 5. So that means that if you place the value of y as negative 8 into this linear equation, you get the value of x as minus 5. Ordered pair of the second case is going to be x comma y is equal to negative 5 comma 8. Moving on to question number 3. Here we have again the first case, which is having a linear equation and a quadratic equation. So firstly, we're going to substitute the second equation into the first equation. And why am I saying that? If you look in the first equation, we have 3x plus y is equal to negative 3. And if you look at the second equation, here the value of y is simply x plus 1 whole square minus 4 into x plus 1 minus 6. So this entire value is of y. So we can write 3x plus x plus 1 whole square minus 4 into x plus 1 minus 6 is equal to negative 3. Now we're going to expand x plus 1 whole square, since that's the first identity, which is a plus b whole square. So we get 3x plus x square plus 2x plus 1 minus 4x minus 4 minus 6, which is equal to negative 3. Now we're going to bring negative 3 to the left side and arrange the like terms. So we get x square plus x minus 6 is equal to 0. Why did I say minus 6 instead of negative 9? Well, if you bring negative 3 to the left side, minus 9 is added with 3. So that's just negative 6. Okay, so now we have this quadratic equation, which is x square plus x minus 6 is equal to 0. So we can further expand it by finding the roots of the equation. So we solve this quadratic equation by factorization method, and the two roots are x minus 2 and x plus 3 is equal to 0. What does this mean? This means that for the first value, x is going to be 2, and for the second value, x is going to be negative 3. Now for these values of x, we can place them into our first equation, which is a linear equation, and find the value of 9. So 3 into the value of 2 is 6. 6 plus y is equal to negative 3. If you take y is equal to negative 3 minus 6, you get negative 9. Moving on to the second case, here if the value of x is placed as negative 3, so the value of y is going to be 6. Now how can we write the solution set of both of these cases? For the first case, the solution set is going to be x comma y is equal to 2 comma negative 9, and for the second case, it's going to be negative 3 comma 6. Moving on to question number 4. Here we have x plus 3 whole square minus y minus 2 whole square is equal to 10. And the second equation is x plus y is equal to 4. Firstly, instead of solving x plus 3 whole square by using the first identity and y minus 2 whole square by the second identity, you can take the difference of squares. Here we have x plus 3, let's say that's a. We have y minus 2, let's say that's b. So we can write instead of this equation a square minus b square. So what is that equal to? That's equal to a plus b into a minus b. So we use that same formula in order to get this in its expanded form. So we get x plus 3 plus y minus 2 into x plus 3 minus y minus 2 is equal to 10. So now we can just simply add x with y and 3 with negative 2 to get x plus y plus 1, and same as for x plus 3 and negative y and positive 2, we get x minus y plus 5, which is equal to 10. So now we have these three terms. What are we going to do? If you look at the second equation, you can substitute any value of x or y. Suppose I want to find the value of x. That means that y is going to be taken to the right in order for its sign to be changed. So that means x will be equal to 4 minus y. Now from this fourth equation, we can substitute it into our equation 3. So we can write, instead of the value of x, we will write 4 minus y plus y plus 1 into, instead of x, we will again write 4 minus y plus 5, and that's equal to 10. So when you substitute the value of x, which we found from the linear equation, into our new equation 3, you will notice that x plus y plus 1 will become constant. Now we have 5 into 9 minus 2y is equal to 10. So we can write here 9 minus 2y is equal to 2, 2y is equal to 7, and if we divide both of the sides with 2, the value of y is going to be 7 by 2. When the value of y is 7 over 2, we can place it into the equation 4, which is x is equal to 4 minus y. We can write, instead of y, x is equal to 4 minus 7 by 2. And if we make the denominator same, our value of x is going to be 1 by 2. So we have successfully solved this equation. Our solution set is going to be x comma y is equal to 1 by 2 comma 7 by 2. Moving on to question number 5. Here we are going to be moving on to the second case, which is that the both of the equations are going to be quadratic equations. If you look at the first equation, here we have 2x squared minus 8xy plus 6y square is equal to 0, and the second equation is x squared plus y squared is equal to 45. So firstly, we're going to take the first equation and divide it entirely by 2, since 2, negative 8 and 6 are all divisible by the integer 2. So we get this new equation, let's call it 3, and that's x squared minus 4xy plus 3y squared is equal to 0. So now we can further expand this equation. We can write x into x minus 3y minus y into x minus 3y is equal to 0. So we got the two terms x minus y and x minus 3y. So that means that x minus y is equal to 0. So in order to find the value of x, we can write x is equal to y. And for the second value of x, we can write x is equal to 3y. So for the first case or branch, if x is equal to y, we can write, instead of the second equation x squared plus y squared is equal to 45, we are going to be writing y squared plus y squared is equal to 45. So y squared and y squared, they add up to 2y squared. We will divide 2 on both sides and take the square root on both of the sides. That means that our answer is going to be positive and negative. So if x is equal to y, that means that both of their values is going to be plus minus 3 under root 10 by 2. For the second case, if x is equal to 3 times the value of y, we can place this value in the second equation. So we will write 3y whole square plus y square is equal to 45. Now 3y whole square, that's equal to 9y square plus y square is equal to 45. So 9y square added with y square is 10y square. We're going to be dividing 10 on both of the sides, and then we're again going to take the square root. So whenever we take the square root, our answer is always going to be positive and negative. So if x is equal to 3 times of y, that means that our value will be plus minus 9 under root 2 divided by 2. So this is our answer. Moving on to question number 6. Here we have two equations which are from the second case, which is the first equation being a quadratic and the second is also a quadratic equation. We have 6x squared minus 5xy minus y squared is equal to 0 for the first equation, and y squared plus 4xy is equal to 30 for the second. So that's why we wrote it as 6x into x minus y plus y into x minus y is equal to 0. So for the first term we have 6x plus y, and for the second term or root we have x minus y. This means that x will be equal to negative y over 6, and for the second value of x it's going to be equal to y. For the first case, if y is equal to negative 6x, we can place that into our second equation. So we're going to be removing this y square and be writing minus 6x whole square plus 4xy is equal to 30. We can further solve this equation, and we have 36x square minus 24x square is equal to 30, and we get 12x square being equal to 30. We will divide 12 on both of the sides and take square root on both of the sides in order for our answer to be positive and negative. So we get the value of x as plus minus under root of 10 by 2. If we have this as the value of x, we can again place this in the equation to find the value of y. Or simply we can use this root which we just found, y is equal to negative 6x. So if you multiply negative 6 with plus minus under root 10 by 2, your answer is going to be plus minus 3 under root 10. For the second case, if x is equal to y, instead of y square plus 4xy is equal to 30, 5y square is equal to 30. 5 is going to be divided in both of the sides. 30 divided by 5 is 6. And by taking the square root on both of the sides, you're going to get your answer as plus minus under root 6. So we know that x and y are both equal, so this value of y is going to be the same for x as well. Moving on to our final question of the entire exercise, question from case number 1, which is linear equation and quadratic equation. Looking at the first equation, we have 4x square plus 4y square is equal to 65. And for the second equation, we have 6x minus 2y is equal to 5. So from the second equation, we can substitute the value of y. How are we going to do that? We can simply just take negative 2y and bring it to the right, and bring this positive 5 to the left. That means 6x minus 5 is equal to 2y. When we divide both of the sides by 2, we get the value of y as 6x minus y over 2. Now this new value of y, it can be substituted into the first quadratic equation. So that means instead of writing 4x square plus 4y square, we will write 4x square plus 6x minus 5 whole square is equal to 65. Now we can simplify this 6x minus 5 whole square by the second identity, which is a minus b whole square. So we get 4x square plus 36x square minus 60x plus 25 is equal to 65. So we get 40x square minus 60x minus 40 is equal to 0. Now this entire quadratic equation is going to be divided by 20. Why? Because 40, negative 60 and negative 40 are all divisible by this number. So we can write 2x square minus 3x minus 2 is equal to 0 instead of our previous equation. Now this equation can be solved from various methods, but we're going to be using the factorization method. So the factors for negative 3x are negative 4x plus x. So we will write 2x square minus 4x plus x minus 2 is equal to 0. Now here, between 2x square and minus 4x, we can take 2x as a common value, and then we're going to divide this value from 2x square minus 4x. So we're going to write 2x into x minus 2, and then we don't have any common value between x and negative 2, so we can just take 1 as the common value. So we have both of the terms x minus 2 and 2x plus 1, which is equal to 0. For the first case, x is going to be equal to 2. Why? Because we brought the negative 2 to the right, so its sign changed. And for the second case, x will be negative 1 by 2, as we brought the positive 1 to the right and divided both sides by the integer 2. So if the value of x is positive 2, the value of y is going to be 7 by 2. Why? Because we simply place that value in this second linear equation. And if the value of x is negative 1 by 2, then the value of y is going to be negative 4. So what are the solution sets for this question? It's going to be x comma y is equal to 2 comma 7 by 2 and x comma y is equal to negative 1 by 2 comma negative 4 for the second case. I hope you guys liked my lecture. If you did, make sure to subscribe to my channel and share this video with your friends so they can benefit from it also. If you have any doubts, feel free to comment that down in the comment section. Thank you.